Hello all, welcome back, and today's discussion is solving a recurrence relation by using substitution method for finding the time complexity of an algorithm. So before getting into the substitution method, first we'll discuss what is a recurrence relation and how we can write a recurrence relation for any algorithm. So first coming to recurrence relation, it is a mathematical expression and basically we are writing this recurrence relation to model the time complexity for any recursive algorithms. Okay, so coming to recursive algorithm, we already discussed about what is a recursive algorithm. That is, if you look at here, I have given an example for finding factorial of a given number, and in this example we have a method factorial, and inside this method you can see the factorial method is calling itself. So this is what called as a recursive call, and this function is called as a recursive function because this function is calling itself repeatedly until certain condition is met, right? So that is why this is called as a recursive function. And if this type of functions are there, then how can we write the recurrence relation for this function? So first let us understand this program. So if we take factorial, we know how to calculate the factorial of a number. For example, if it is given as n factorial, in general, how can we write like finding n factorial? N into n minus 1 into n minus 2 into n minus 3 up to we'll go for 1. In the same way, if I want to find the factorial of a number 5, so how do I write it? 5 into 4 into 3 into 2 into 1. So this is how you can find the factorial for any number. And coming to factorial of 0 and factorial of 1. If you take factorial of 0, the result will be 1. And if you take factorial of 1, again the result will be 1. So for factorial of 0 and 1, the result is same, which is 1. Whereas for the other values, you need to use this formula and you can calculate the factorial of a number. And the same thing I have written here in the form of code. So if you check here, we are first checking the condition of n. That is whether n value is equal to 0 or n value is equal to 1. If n value is 0 or 1, then it should return the value 1 because we know the factorial of 0 and 1 is 1. Otherwise, what you have to do, you need to check for this formula, right? So that is what written here, n into factorial of n minus 1, which means n into, again you are calling this method and you are checking for the next value, that is like previous value, n minus 1. So let me take this like n value as 3 here and we'll try to find how it works. Okay, if n value is given as 3, first it will check the condition which is false. If it is false, it comes to this statement, and here n value is taken as 3, so 3 star, then it will call factorial of n minus 1, which means factorial of 2. So here again this function call comes here. Now n value becomes 2. Okay, so it will check the condition again, which is false, so it comes to this return statement. Now n value is 2 multiplied by, then it calls factorial of 1. Now it calls this, n value becomes 1. So now it checks the condition. So you can see here n value is 1. So if this condition is true, then again this statement will get executed. So which will return the result 1. So which will not come to this place. Okay, directly it will return the result 1 and the block gets like completed. It will exit from the block. So this is how this code works for this value. If you see here, how many times this call is happening, how many times this recursive call is happening in this code for the value 3. I have given n value as 3, and if you see here how many times the recursion is happening, it is happening for 2 times. What if my n value is 4? So first it will execute the statement 4 multiplied by f of 3. After that n value becomes 3, then this will happen. So if my n value is 4, then how many times the call is happening? Recursive call is happening for 3 times. Okay, so which means in general you can say that the recursion is happening here for n minus 1 times. Okay, and coming to this one, this result 1, so which is checking the condition and it is returning the result 1 for 1 time. Okay, so by this we can able to write our recurrence relation. So that is what I have given here. If you take this, see, if n value is less than or equal to 0, okay, sorry, if n value is less than or equal to 1, not 0. If n value is less than or equal to 1, then it will return the result 1. Otherwise what will happen? So how many times this method will execute? This method will execute for t of n minus 1 time, okay, which is the time taken for this recursive call, and plus 1, and this plus 1 is for printing this result, returning this result. Okay, this is how I have written the recurrence relation for this method factorial. Right. So now by keeping this recurrence relation, we need to find the time complexity of this algorithm, that is for this program factorial number. How do we find the time complexity? By using this recurrence relation. So for that only we have substitution method. Okay. So we will see what is that substitution method. Yeah, and here is the substitution method, and if you see here, there are two substitution methods to solve this problem. One is forward substitution and the other one is backward substitution. First we'll see what is forward substitution, or how do we apply forward substitution to solve this recurrence relation. Okay, if you take forward substitution method, you need to set some initial conditions. Okay, so we know that for the value n greater than 1, we will get this recurrence relation, that is t of n is equal to t of n minus 1 plus 1. Now for this I am setting an initial condition as, that is my t of n is equal to 1 and n is equal to 1. This is my initial condition for this recurrence relation, that is t of n which is equal to t of n minus 1 plus 1. Okay. Now what I need to do in forward substitution means you need to proceed by substituting n values starting from 1, because we know the condition, it should be greater than or equal to 1. So what if I substitute the value t of 1? So what will happen? T of, instead of n minus 1, so what will happen? 1 minus 1 plus 1. So which means t of 0 plus 1. So here t of 0 is 0 plus this value is 1. Now you found that t of 1 is equal to 1. In the same way, you need to substitute 2 for n value. If you substitute 2 for n value here in this equation 1, then what you will get? T of n minus 1, which is 2 minus 1. So you will get t of 1. T of 1 plus 1. Now what is the value of t of 1? That we found here as 1. So 1 plus and this 1. Now what is the value here? Which is 2. You found that t of 2 is equal to 2. In the same way, now try to find the value of t of 3, which is equal to t of n minus 1. So 3 minus 1. 3 minus 1 is 2 plus and this value 1. Right? Now what is t of 2? T of 2 we found here as 2. So 2 plus 1, which is equal to 3. Now we found that t of 3 is equal to 3. So t of 1 is equal to 1, t of 2 is equal to 2, t of 3 is equal to 3. In that case, we can generalize this as t of n is equal to n. So now you found the complexity of that factorial problem as t of n is equal to n by substituting, by which substitution? Forward substitution. Right? Now we'll see, we are going to solve the same recurrence relation but using backward substitution. So how backward substitution works, and we'll check whether we are getting the same time complexity by applying backward substitution. Coming to backward substitution, how do we apply backward substitution? So this is the recurrence relation that we found for the problem, right? And for this recurrence relation, how do we apply backward substitution? So first you need to find t of n minus 1. What will be the result of t of n minus 1? So you are going to substitute n minus 1 in place of n in this equation. Okay, so this is my equation. Now instead of n, you are going to substitute n minus 1. So what if you substitute n minus 1? So this equation will be written as, instead of n, I am going to substitute n minus 1, and here already minus 1 is there. So minus 1 plus 1. So this will gives you t of n minus 2 plus 1. Now I found the value of t of n minus 1 as t of n minus 2 plus 1. Okay, so now what happens? This is my equation 2. I found this equation. Now what I can do is I can substitute this in this equation 1. So that is t of n, which is equal to, instead of t of n minus 1, what I can do, I can substitute this one. That is t of n minus 2 plus 1. So this is the substitution for t of n minus 1, and again in this equation you already have plus 1. So you need to add plus 1. So finally what you will get, t of n minus 2 plus 2. Okay, this is the formula which you derived. Now this is my third equation. Okay, now again you need to find the value of t of n minus 2. Okay, so how do you find t of n minus 2? Same way how you found t of n minus 1. So you need to find t of n minus 2 by substituting the value of n with n minus 2. So if you substitute n with n minus 2, here what will happen? T of, instead of n, we will write n minus 2, again minus 1 plus 1. So we will get t of n minus 3 plus 1. So this is my next equation. Now what I want to do? So this equation I found for t of n minus 2. So I need to substitute this equation here in this one. Okay. So in equation 3, what I am doing? I am going to substitute t of n minus 2 as t of n minus 3 plus 1. Okay. Then after this what you have? Plus 2. Okay. Now how can I write this? T of n minus 3 plus 3. Okay. In the same way again I need to find the equation for t of n minus 3, and then I have to substitute here. If I do that, again what will happen? So instead of t of n minus 3, so what I will get means t of n minus 4 plus 1. Okay. Then this plus 3 is there. Just add this plus 3. Right. Now how can we simplify this? N minus 4 plus 4. So this is the equation which I will derive next. Okay. So if you look at this pattern carefully, you can see here t of n value is equal to, if you substitute a constant factor for this value, constant value, you can generalize this formula. How can we generalize this formula and write t of n is equal to t of n minus, instead of all these values 2, 3, 4, and if you substitute again you will get 5. So instead of that I am writing it as k, a constant k, plus again here also you are having the same constant. I am taking it as k. Okay. Now I am going to assume that my n minus k value is equal to 1. Okay. So if I keep n minus k is equal to 1, then what will be the k value? So n minus 1 is equal to k. Okay. Now I found the value for k. Okay. Here I am assuming that what? N minus k is equal to 1. So which in case I will get k is equal to n minus 1. Now I'm going to substitute this n minus 1 for the constant k in this equation. That is the general equation which we derived now. Okay. So in that case t of n is equal to t of n minus, so instead of k I am going to substitute n minus 1. N minus 1 plus. Okay. So again n minus 1 because you have k here. So instead of k I am substituting n minus 1. Now what will happen if you solve this? So t of n cancel. I'm sorry. So here you will have a bracket because for k, instead of k you are going to substitute n minus 1. So there will be a bracket here, and if you take it out like n minus plus 1, sorry, n minus n plus 1, you will get like this, and then this will get cancelled. At last you will get t of 1 plus n minus 1. We already know the condition in recurrence relation that if n value is less than or equal to 1, then it will return 1. So we are taking that condition here. For t of 1, we are simply assigning value 1 plus n minus 1. Then finally we will get the value n. So in backward substitution also we derived that T of n is equal to n, and in forward substitution also we derived this as T of n is equal to n. So this is how forward and backward substitution works for a recursive algorithm.